Today we are talking about the Monte Carlo method. So, what is Monte Carlo method? Let's we can see the definition from the 112 website. It's using pseudo-random numbers to solve not so random problems. Okay, although it's from 112, it's kind of confusing. So what exactly it means, right? So basically, it's saying that we are doing bunch of trials of experiment to find the probability of certain event, random event. So here's the calculation of it. So it's the number of successful trials over the total trials. So you do a bunch of trials and see like how many trials it actually give you the outcome you want. And as the trials number gets bigger, approaching infinity, the probability should be approaching the theoretical probability. So your calculation will be finer when you do more trials. So let's combine it with an example. To find the probability of two dice landing the same number using Monte Carlo method.
First, we'll find the theoretical probability by computing, and then we'll look at Monte Carlo method of solving it in two ways. So, using the mathematical calculation, there are 36 total outcomes, and the total number of successful outcomes is 6, which is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So 6 divided by 36 is 1 over 6, which is 16.66% approximately. So that is our theoretical probability. Now we're heading over to Monte Carlo time. It's the experimental method of Monte Carlo. So I will draw the dice 100 times and record the number of times that um, the dice landed on the same number. So here we go. It is 1 5. Um, we got 18 successful trials where the numbers landed are the same, and out of the 100, so that approximates to 18%. The actual number is 6 over 36. The actual probability is approximately 16.66%, I believe. So yeah. So in this example, we're going to find out the probability of rolling two dice and getting the same number. And to do so using the Monte Carlo method, first we're going to create, we're first going to import, but first we're going to create a function called roll die. This would represent an outcome that a dice would give, which we assume there's 6 sides, and first then we have to import random and use ran.int from 1 to 6 side. Next, we're writing function roll dice. Function roll dice would be the combination of rolling a die 2 times, and that combination can be anywhere from 1 to 6 for the first die and 1 to 6 from the second die. It returns a list. Next, we're going to find out if the trial that we can make rolling two dice is successful or not. So trial succeed is going to count if the number in that combination is 2 or not. So we're going to go over a for loop from 1 to 7 and see if the count of that number is equal to 2 or not. If any of them 1 1 2 2 3 3 4 4 5 5 6 6 is equal to 2, it will return 2, else it will return false. Next, we want to know the probability of those trials being successful or not. So we're going to count how many times of 100 trials will trials succeed, our pass function return true. And so if trial succeed returns true, we're going to count plus 1. and we'll run how many times we do it successfully. So first, when we do 100 trials, we get 13%. As the trial increase, the probability gets more accurate.
So Monte Carlo method is great, but there are some limits to it. So as the definition said, we are using pseudo-random to find out the probability of certain random event. But pseudo-random is not random, although it appears to be. It's actually generated by a very deterministic causal process inside the computer. Despite the limits, Monte Carlo method is still used a lot in a lot of mathematical and scientific fields. So hopefully from this video you learn something and how to use it.